Hi, everyone. Good morning. My name is Jason, and I'm a solution architect for Keysight. Actually, today's topic, I'm talking about test. My specialty is actually more on the network visibility side, but today I'm going to talk about test because I'm fascinated with the subject. So let's get started. Okay, so you know that there has been 5G networks rolling out in the world. I think in Europe we have Germany, UK, and a few other major countries like Switzerland already roll out gradually their first phase of 5G implementation. And also in Asia, we see actually quite substantial growth of subscribers, specifically in South Korea. Any audiences from South Korea? Because I did see a few. So all three their major carriers already implemented 5G on their radio side, and I believe they run at 3.5 gigahertz spectrum. So what does 5G mean for an end user? What's the benefits? The benefits are quite substantial. Not only it delivers higher bandwidth, 10 to 20 times as much bandwidth, and the cells can be a lot denser. So we can accommodate more than 1,000 times per square meter. So once you have 5G, that's what they say, is that you can go to a football stadium full of people, like say, for example, 100,000 people, and you won't be able to, everyone will be able to watch a live cast from his mobile phone. So if you try this today, you might have trouble even try to conduct a phone conversation, right? And also the most important thing about 5G is the reduced latency. So this is very important for IoT communications, right? For M2M, very low data rate, but requires less than 1 millisecond of response time. And it also brings out what they call the killer app. What they think is very important is augmented reality, and also, for example, if you have, like, say, online gaming or game streaming right to your mobile device, it becomes very important to have very low latency. And it also enables M2M communications. But this is on the user side of perspective. What about for the operator side? What's the benefit? The biggest benefit is that, first of all, there's always been a scalability problem for the existing 4G networks. And in 5G, the core networks, they introduce a whole bunch of SDN-based ideas and standards, which they can scale out horizontally. So historically, we have the MMEs and the S-gateway being the choke point. Now, the one that's actually delivering user plane traffic can scale out horizontally. And also, if you look at the diagram on the left side, it represents very closely to what we have today in the 4G core infrastructure. But on the right side, this is where they're moving to, is that the promise that every core node can be virtualized into like, say, how do you say, off the shelf hardware and on a hypervised environment. So potentially it will deliver same level of service at a far lower cost to the carriers. But of course, there are various challenges for this kind of implementation. Mainly has to do with the virtualization itself. There's always resource contentions, and each of the nodes will be what we call the noisy neighbors, and you have to find a way to isolate them, to be able to operate with a deterministic response time and as well as bandwidth. So actually there's a lot of trial and error and testing involved in that. And this is where Ixia, historically, we've been helping not only the network equipment manufacturers, but also the operators to help test and implement new solutions. For the network equipment manufacturers, they purchase Ixia to find out bugs during the development stage, and also for the carriers, for the operators, they use Ixia to make sure that the throughput is there, and also there is no any, like, say compliance or any network issues due to protocols not being able to talk with each other. And one other topic is very prevalent today is the automation side as well, because everyone's moving into an orchestrated environment, and they need some kind of integration, not only the management system, and also for the test. On the test side, they're also looking for automation. Okay, now moving on to how the carriers actually move from existing 4G to 5G networks. Actually, 3GPP has come up with 7 different options for operators to implement to actually transition from 4G to 5G. The most popular option we've spoken to various carriers, and we find out that the most popular is going to be what's called the option 3X. Actually, in each of the options, there are several sub-options as well. But the advantage for option 3X is that the existing 4G or LTE eNodeB can coexist with the new radio, which is 5G eNodeB, and they connect to an existing 4G core infrastructure. Okay, so with the eNodeB being the master node, and 5G being the secondary node. In this way, they have data paths directly to the 4G infrastructure, but at the same time, they also allowed communications between the node Bs. So in the initial phase, there are going to be separate entities for the eNodeBs on the 4G side and 5G side. But in the long term, these will be combined. They will be virtualized, as what they say. Okay. So how do they, when they implement this, how do they actually test this out? So in our product portfolio, there's a long, very well-known product called IXLoad. This comes with both in physical form and also a virtual edition. Okay, so they can run with as VMs. What they do is that we can actually emulate the EUEs, which is the handsets, right? The EUEs and also the eNodeBs, as well as the infrastructure that connects to the internet side. So the DUTs, the device under test will be the core infrastructure itself. Okay? And we have expanded this IX load to support the initial implementation of 5G, which is what we call the CUPS integration, which this is the very, very important subject in 5G development, is that there has to be some kind of horizontal scaling on the user plane side as well as the control plane side. So the diagram doesn't reflect this, but if you see the S gateway and the P gateway, SGW, PGW, in the initial 5G implementation, these are actually separated into separate control and user. Okay, and there are 3GPP specifically devised protocols to support these functions. They call the SX interfaces. So they are the XSA all the way to C. Okay, and we can support this today. In addition, we support G-No-B emulation as well. So you can actually run a complete option 3X test when you're implementing your initial 5G networks. Okay, and in the longer term, this is where all the service providers are trying to reach is the option 2, which is a standalone 5G radio only. So because the operators usually they won't have enough financial capability to actually transition all of a sudden from 4G to 5G. So they'll need they'll actually implement this throughout over a few years. And option 2 is all they're trying to reach to, which is pure 5G radio. And at the same time, they will have a 5G core. Okay, they'll transition to a 5G core. So at Ixia, we figured out because all the interfaces in 5G core networks are totally different. Okay, especially for the control plane that they're moving on to more like a HTTP2 based protocols for the control plane, and the user plane stay as same as 4G. And there's a lot of movement in terms of virtualization. We decided that we will actually use this opportunity to come up with a brand new tool just for the 5G testing. Okay, we call it the 5G core test engine. Okay, and this screenshot is taken from one of the basically the main control plane from that test engine, and as you can see, it reflects 100% what's been laid out logically in the 5G node, with each running different interfaces compared to the 4G. So the beautiful thing about this is that you can basically mask out any of the node in this control plane and use that as a device under test. So in this example, we have the AMF, which is equivalent in 4G as MME, and also the SMF, that is the session management function under 5G, but it kind of reflects the partial functionality of the MME plus the serving gateway. Okay. So the one that they're showing blackout is because they are being devised as the device under test. Okay. So and we actually emulate the rest of the entities in the core networks, including the EUE, and the G node Bs. Okay, so you can basically simulate any of the core networks nodes to be able to apply that to your test cases. Okay, and these are just some screenshots on the parameter for each of the nodes, and you can actually specify different, like say for example, for your user plane, you can actually devise multiple of them running in parallel. So to actually simulate what's actually happening in the 5G core. And these are some of the screenshots when the test is actually running for the UE, like for example UE attachments, the actual throughput and the transaction rate for each of the interfaces. Okay. So one of the use cases that we have is that we want to test the user plane only. We want to test it for example, not only for functional test, but also we want to apply some load tests, actual loads. And this is achievable for under 5G CTE, but also we can use the existing IX load because as I said before, we have capability to emulate G node Bs and UEs from the IX load. So this is available either you can purchase as a VM, okay, or as a hardware if you want to do like say high capacity testing, or you want to measure the actual latency in your 5G core nodes. On the UE side, we have the capability to actually detect the QoS level. So you know during test what kind of response your core infrastructure is giving you. The other use case here is that you actually want to conduct the entire core test for 5G. And this is also possible. We can actually simulate thousands of G node Bs out there, okay, and as well as UE, and also on the internet gateway side, as well as some the user authentication infrastructure as illustrated there. Okay, so AMF testing, basically we'll be measuring the performance on the N1 and N2 and 3 interface. These are mostly very important for the 5G core. Okay, and also there are test cases we can use for horizontal scaling test, especially when you're scaling out your SMF or your user plane functions. These are also possible as we can devise multiple of SMF and also the UPFs, and we have the ability to isolate certain server space architecture nodes. Okay, so the UI is actually very light. It was written entirely in REST API, and it is container based. So it's very light and fast. In fact, my colleague has a demo. You can come to our booth. He can show that to you. You can run the entire test from a single laptop. All the parameters are very clear, very user friendly, and you can define whatever topology you want to test. Okay. And also, of course, people get lazy nowadays. They want to automate everything, and since the the user interface itself is written with REST API. We can use the same REST API to allow different, like say, Python scripts, or you can integrate that into your orchestration environment, for example. And then we have presets on our REST API client, and you can actually devise different parameters or test cases for that. Okay. And as for how the 5G core testing engine is deployed, it's actually very flexible. You can run as a VM on the environment of your choice, or you can run as a container under Linux, or you can run as a container inside the Kubernetes pod if you have the requirement for that. And even you can run it in the public cloud environment, such as Amazon, AWS. You also have the option to actually install the entire thing on the bare bone on the Intel server for that purpose, so you get better bandwidth. And that's the end of my presentation. Any questions? Good? We're good?
Hi, my name is Sander Brouwer. I'm from Product Consulting. I have a question on your test approach towards scaling out of individual network elements. Can you elaborate on that?
Do you want to answer? You want to come to the stage? No, I can have my colleague to answer that question regarding scaling out. So his name is Ruben, and he's an expert in 5G testing.
Hi. Okay. So can you be a little bit more specific?
Well, Jason started off by describing one of the key characteristics of the standalone core network as the ability to scale out as needed. So I was curious about the test approach to test that very capability.
It's for the SX interfaces, between the MMEs and also the S gateway and GP gateway. Go ahead, you do it.
So the approach is that if your network is automated enough, it is going to scale out. So you can just ramp up into the traffic that is reaching to your network, and it will be forced to scale out. So that is the basic approach.
Did we answer your question?
I can understand that from an end-to-end perspective, but if you're taking individual nodes in isolation, does that still apply, or do you potentially need to tweak certain parameters in the elements themselves in order to get to that threshold where it needs to be scaled out? Or it's the only approach to generate a shitload of traffic?
Well, in this specific case, there is no point on isolate only the part that is going to handle the traffic, but also your controller. So you want your own controller to be able to give the order to scale out. So it makes sense that our approach should be only to scale the traffic till the point that you have this threshold and your infrastructure is going to give the order to scale out. We consider this is the best approach in this specific case.
Okay, thank you.
You're welcome.
Other questions?
I'm sorry. We have actually run out of time.
Yeah.
If there are other questions, you're free to contact Jason and his colleagues in the lobby. You are going to continue
Yes.
your presence here. Excellent.
Exactly,
Thank you very much, and thanks,
Okay,
Jason.
thank you.
Thank you.